In this lesson, we're going to be talking about doing data validation under Linux. And by data validation, what I'm talking about here is when you've acquired some evidence and you want to make sure that you have preserved the state of that evidence in a way that you can go back and say, yes, this is the state that it was in when we first acquired it. It hasn't been altered. It hasn't been modified. No changes have been made to it. So we need to be able to do some verification of the evidence that we have. So one of the very simple ways of doing data validation is we could do something like a diff, which is a differential between two different files. So I've got a whole bunch of files here, and I could do a copy here of a README file, and I'm going to call it readme.new. Now, if I do a difference or a diff on readme as compared to readme.new, I'm going to get no differences. If I make some changes to readme.new and then do a diff again on it, I can see that there are some changes there. So this doesn't do anything other than just a very simple comparison of two different files. It may not be enough to hold up against serious inquiry in a court case, but it is one way of just doing a simple comparison to see if a couple of files are the same or whether they're different. One thing that you really want to be using is a cryptographic hash, particularly when you've got a disk image that you have been working on to find evidence in. You want to be getting cryptographic hashes of the image so that you can say, this image hasn't changed since we acquired it. Here's the original cryptographic hash, and this is the cryptographic hash now. You can see that it's the same. So one of the ways of getting a cryptographic hash is a program called MD5Sum. And MD5Sum, not surprisingly, does an MD5 hash. And I can do an MD5Sum of the README file. And there's the cryptographic hash of that file. I can do a cryptographic hash of the readme.new file. And you'll see that there's a difference between those two cryptographic hashes. A cryptographic hash will generate a value that is the same length regardless of the length of the input. So you are always going to get the same length output from an MD5Sum no matter how big the input file happens to be. I could have a multi-gigabyte disk image and it's going to generate the same length hash as these short files. So same thing with SHA-1, which is a more advanced cryptographic algorithm. And you can see it generates a longer hash. And once again, I can do a cryptographic hash of this other file. And you can see again that we've got a different cryptographic hash with these two different files, which of course is to be expected. Cryptographic hashes shouldn't generate the same hash with two different inputs. So no matter what input I throw into these hashing algorithms, I should always get a unique output. And the problem with MD5, which is generally okay for validation for these purposes, but the problem with MD5 is that we've run into the situation where we have things called collisions, where two different inputs end up generating the same output from the MD5Sum. And once you run into that case, from an encryption perspective, we end up with the potential of maybe breaking encryption. But since there's less of a chance of that happening, or there's a small chance of that happening, generally the MD5 is considered okay for validation of data. To be safe, though, using something like SHA-1 is a better tool to use. So SHA-1 is a better tool to use, or in this case, SHA-1 sum is the name of the actual tool or utility. So you'd use a SHA-1 hash in order to verify or validate the data that you are using and ensuring that it hasn't changed over the course of time and working on it. One tool that you can use in the process of actually getting the image or the data is this tool called DCFLDD, which will generate a hash as part of copying the file. So you can see here we've got hash equals name, and you can say MD5, SHA-1, SHA-256, SHA-384, SHA-512. Now the copy part is the same as the DD utility. The DCFLDD utility adds some other capabilities, one of which is this ability to generate the cryptographic hash as part of the copy process. So once it's done with a copy, it will generate a cryptographic hash of the copied file. So we can use that down the road in order to verify or validate the data that we've got. It's the same thing as using DD and then doing an MD5 sum or SHA-1 sum. In this case, the DCFLDD compacts that into one call rather than two separate calls. So it's the same thing as doing the two separate utilities. In this case, it's just running one utility in order to get the copy and the hash. But the hash would be completely the same no matter which way you ended up doing it. So that's a few different ways of doing data validation under Linux.